Welcome back. So this is still a 7677B. I've already made two videos, part 1 and part 2, and that covered the front page of the in-class notes. That looked like the following. So in-class 7.6B, 7.7B, these notes are on your Canvas account, as always, and the entire answer key for both front and back are on there as well, so that you can check your answers at home, just in case you're home sick. You can watch the videos, obviously, and you can also check your answers. Okay, great. So what are we gonna cover now? Well, we've covered this whole front part in the two videos I've created thus far. It's this now. When banks pay interest on both the principal and interest, the bank is paying what is called compound interest. Compound interest is an example of exponential growth. So we're going to do some work with what we call compound interest versus simple interest. So a quick little side note on these. So let's say you invested some money in a simple interest account versus a compound interest account. And let's say you invested $2,000 at 5%, which is never gonna happen, but that's a pretty high percentage. Okay, so you invested this, or you placed this principal of $2,000 in the bank, and it's gonna pay 5% interest. So if you did 2,000 in your calculator times 0.05, what you're gonna get is $100. Both of them are gonna earn $100 for a certain time period. But here's the difference. They both have $2,100 in their account. The next time interest is earned on this simple interest account, you just earn another $100. You earn an interest on your principal. So you keep earning more interest, which is kind of like a little thank you from the bank for keeping your money at their bank, right? Little interest is a little bit of extra you get. You're gonna keep earning that $100 each time period. But that's it. This one is different. So here's my principal. It's the amount of money you placed in the bank. Here's your interest. And there's your new amount. Now they take this new amount and they determine 5% of the new amount. So the next amount that you're gonna earn is $105. Now you're at $2,205, whereas this is only at $2,200. They have $5 more than you. And I know you're like, who the heck cares? It's only $5. Well, if you keep doing this, so they get their next 100, you get 5% of building on the principal and your interest. You build on principal, interest, and interest, whereas this person only builds on the principal, the original amount that they put in the bank. Now, if you keep going, the next one is going to be $110.25. So this accounts up to, nice. Now, who cares? This is at $2,300, that's only $15 extra. But if this keeps going, think about that. This is a linear growth. If I looked at a little graph, so for a certain time period over time, this is the dollar amount. You started at 2,000. This account's gonna go, boop, 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 boop. It's gonna grow, no doubt, it's going to grow. But it's gonna grow in a very linear pattern. For every one time period, it's gonna grow $100. Every one time period, $100. So it's time period 100, time period 100, time period 100. It's gonna be a linear graph. Whereas this one is a beautiful example of an exponential function, exponential growth to be precise, because it's growing exponentially. Notice it started at the 2002, but it's gonna do that. So this is our simple interest line, and this is our compound. Which one's gonna grow faster? Because it's growing exponentially. I mean, this one's good. It's growing linearly in the shape of a line, but this one's growing in this beautiful curve. Cool beans. Let's get started and talk about how to use the formula to determine the amount of money that we have at a certain rate, at a certain time period, Under what terms, okay? So I'm going to erase, and we're gonna get started. So the formula is not one you have to memorize. There is no reason to memorize the formula. But let's take a gander at this beautiful formula. I'm gonna scoot you up a little bit. Ah, you're close, Miss Miller, I know. Hello, welcome. Okay, cool, okay. So here's the formula. Now, I've let you know what each one of them is right here. Okay, so A is the amount in your bank account. A represents your balance, your amount in your bank account. P represents your principal. That's the initial amount that you placed in the bank. Was it $2,000, $12,000, $100, $50,000? How much did you put in this account? Now, it's going to be 1 plus a bit more. Remember, growth is a B that's greater than 1. And 1 plus a bit makes that growth factor, right? So it's a bit more. R stands for the rate. What is the percentage that this money is growing? Now, in my example I used was 5%, right? So 0.05, we turn it into a decimal. So what's the rate? What is that decimal amount that it's growing? N stands for the number of times the interest is compounding in 1 year. Is it going to be monthly? Monthly. How many months are in a year? 12, right? We have that here. Is it growing monthly? Is it growing quarterly, 4 times a year, so every 3 months? Or is it growing annually? And I noticed I used the word yearly in there too. That's not really, that's simple interest to me. This is simple interest. These are growing, boom, 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 it's growing a lot. Okay, now, and what does T represent? T represents the amount of time that you're leaving it in the bank in years. And there is a multiplication dot right there, just in case you're like, what are those 2 letters? When 2 variables are sitting side by side, it's a product, it's multiplication. Cool beans, let's look at our first question, why not? Let's do this. First question, you deposit $30,000 in a bank account. Cool. The account pays 11% annual interest compounded monthly. I'd like to know where that account is. I will drop all my money in there. Find the balance after 5 years. So now let's read it again and underline what we think might be important things. You deposited $3,000 in a bank account. That's your principal. That's that starting amount, that initial amount that you placed in the bank. The account pays 11%. That's your rate. That's your R value. Bloop, bloop. And we have to turn it into a decimal. So our R, or rate, is 11%. Now keep reading. Find the word compounded, and then the next word gives us a big woohoo. It gives us the N, the number of times our money is building. Annual interest compounded monthly. Monthly. Oh, you can't see that. Let me turn it a little bit. Monthly, there it is. Monthly means 12 times. So the number of times our money is growing is 12. So there are 12 months in a year. And then how many years? 5 years, and it's written in the proper form, in the amount of years. So I'm gonna write down the formula, and then I'm gonna fill it in. So my amount in my bank is the principal, and it's a growth, so it's 1 plus a little bit, so R over N, and N times T. Cool, let's place all of our numbers in these special locations. Principal, 30,000. 1 plus, the rate is 0.11, all over the number of times it's building, which is 12, and then it's going to be 12 times T. Now, I would suggest you multiply that out, get it done. So 12 times 5 is 60. Cool. And now you literally can put this in your calculator and it will pop out the answer. How do you stick this in your calculator, Mrs. Miller? That's where the mystery is. Okay, cool. Let me explain. First thing you're going to do is type in this into your calculator. Nice. You're going to use that parenthesis. Do 1 plus, and then 0.11 divided by 12. Because a fraction means division. So it's 0.11 divided by 12. So we have our 1 plus 0.11 divided by 12. End. Now you're going to have to find that really cool button, and then 60, and then hit equal sign. Cool. And again, let me twist it a little bit. There you go. And then if you put all of that into your calculator, now your cell phone calculator, when you turn it sideways, becomes a scientific calculator. That's a really awesome one. You can try it in there as well, okay? So the approximate answer would be, it should be right here, and here it is. I got 30,000 in class. So $51,867 with a little dollar sign in there. Now, if you're using your cell phone and you're not getting this answer, your cell phone calculator, you might have to tweak it and figure out how to do those buttons in what order so that you do get this answer. That might take a little bit of TRY on your side, okay? So I'm gonna end the video right here. If you wanna tackle the next 3 on your own, give it a try, and then we'll come back for video number 4. Have a great day. Bye.